Yeah, so what's Flyte agent? So agent is a long-running stateless service. They can be used to execute tasks, especially for the like web API tasks or sensor. So it's designed to like communicate, talk to the external service. Like we can submit a job to the BigQuery console, or like we can check if the file exists in the S3 bucket. Like, and then we design a simple API interface, which allow people to easily to extend to add a new agent in Flyte. So here you can see like every Flyte agent service is essentially a Java server, and then it runs many different kind of agent. Each agent handle different kind of tasks, and then you can have two agent service, one for production, one for development. The reason why is, we do that is that people can, when people want to add a new agent, they can add it to the development Flyte agent service. So when the agent shut down for some reason, it will not affect the production environment. And then we add a new JavaBC client in the Flyte propeller, and propeller will send the request to the agent service and based on the text type. So some people may have some question about what's different between Backend plugin and the agent. So in the propeller, we have two kind of plugin. The first plugin is called KS plugins. It used to create a new pod to run the task. For example, when we run the Python task, it will create a pod, and this pod will run your Python code. And then when you want to run like TensorFlow or PyTorch job, KS plugin will create a custom resource, Kubernetes custom resource. And here is like, for example, like TensorFlow job or PyTorch job. And then you will create mutable pod and run the distributioning. And on the other hand, the Web-App plugin, instead of creating a new pod, Web-App plugin will send HTTP requests to the external system. For example, send a query to the BigQuery, and then if you want to run like Spark on the Databricks, send a Spark text to the Databricks platform or like Snowflake, etc. So basically the agent is going to replace the Web-App plugin. So we want to decouple the agent from the propeller. So we use the Flyte agent to handle this Web API tasks or like file sensor to check if your file is in the bucket. So why do we want to decouple the plugin or agent from propeller? So the reason why we do that is that we find that a lot of people struggling with adding the new Backend plugin in Flyte, because Backend plugin is written in Golang, and then most of our contributors are not familiar with Golang, and they want to write the Backend plugin in Python. And then we define the agent interface in the Flyte IDL. So basically you can generate the server code in different language. And then for now, we add some agent in the Flyte key. So it's enable you to easily to test or test your agent in the local execution. And then another thing is that agent is completely different server from the propeller. So you can test this agent independently. And then the most important thing is that when you run more tasks, there's more overhead in the propeller. So in each Kubernetes cluster, you can only have one propeller. So we want to find some way to handle more requests. So we decouple the agent from propeller, and then every agent is stateless, so you can easily to scale out or scale down your agent based on your workloads. So here we take BigQuery text as example. Here, without agent, you have to write a backend plugin in Flyte plugin repos. It's written in Golang, and then you have to update the dependency in propeller, and then recompile it. You have to figure out how to update a dependency in different repo. And then you have take a long time to build an image for Propeller. And then you have to update the config map to enable the plugin. And then you restart the Propeller deployment. And then you have to register a new workflow. The reason why is because you cannot use Flyte to run the Golang code to run the backend plugin. So to test it, you have to run the workflow remotely. And with agent, you can simply add a new plugin in any Flyte plugin, and then you can add dismissing. I will talk about this in demo later. You add dismissing to your tags, which allow you to run your tags in the local execution. That's it. So it's very easy to test and develop. Okay, let's do some demo. Here, can you see my terminal?
Yeah.
Yep.
Okay, thanks. Here. Here we have a BigQuery agent. BigQuery agent is inherent from the agent base. Agent base is a gRPC. Is a class generated from the protobuf. It's a gRPC server class. And then what you need to do is that you have to implement 3 methods: create, get, delete, and then Propeller will send the redirected request to the agent, and the agent should know how to create a job or delete a job or get a status. Here, for example, like Propeller will send a text template to the agent. In the Flyte key, we will serialize every text to the text template. So the text template contains some metadata of the text, like text input-output interface, or like job config. In here is like, in this text template, we have BigQuery config here. So in the create request, in the create function, we get the project and the location of the data table, and then we use BigQuery client to send our query to the BigQuery console. And then we will get the job ID here. And then we return this resource metadata to the Propeller. Propeller will save this metadata. We will not save the state in the agent. So Propeller will save this metadata in the memory, and then you will also persist in the S3 bucket. And then next time, Propeller will periodically code agent to check the status. Here, we get a job ID from the Propeller, and we use BigQuery client to get the status here. So if the job succeed, we update the status, and then we create a structured dataset output, and then return to the Propeller. If we not succeed, we just return running here. So if we succeed, Propeller will just start running the downstream tags. And here delete, we just cancel the job in the BigQuery. And then here, and finally, we register the BigQuery agent. And here in the text, you just need to add the missing. Async agent executed missing. If you added this missing, the Flyte will try to mimic the gRPC server behavior and try to code the agent code in the local execution here. Here, this missing. We have one function called execute. So when you run the Flyte workflow locally, it will call this function. Here, this missing will try to get the agent based on the text type. And then you will code create a job, like submit a query to the BigQuery console. And then here we have a while loop, and then periodically check the status, and then the job will finish until it returns the succeed. And then after job succeed, we return the output, and then use this output will use for the downstream text. And yeah, that's it. And then here is another, and then you can here this is a BigQuery example. Without agent, you cannot run this workflow locally because the BigQuery plugin is written in the propeller. And then for now, you can, I have a task, try to run the query in the BigQuery console, and then print the output in this by using structured data set here. Example. You will try to running the agent, and then try to convert the output to structured data set. Yeah. So for now, there's no data in the table, so just print nothing. And here there's another example for the I wrote example for the sensor. Here you have a task. This is a file sensor. This file sensor only take one argument is passed. You will check if your file is 6. If it is 6, you will return succeed. Yeah. Only take one argument, and then you can check the agent. In the agent, we try to you get a path from the text template, and then return it to the propeller. And then in the get request, you use fspec to check if the file is 6. If it is 6, we just return succeed. And then otherwise we return running here. And then you finally register the agent. Here is my example here. I have a sensor. If I find the file, I will run the T1 text here. But now it didn't find the file, so it keep running the sensor. And then if I add the file, yeah, and then it will stop running the T1. So, and I'm going to talk about how do we deploy the agent. So to deploy the agent, you have to build a image for your agent deployment. Here, here's a Docker file. The only thing you need to install is the your plugin or your sensor. This plugin have a Flyte sensor, and then you the entry point of the Docker file is Flyte serve. Flyte serve is essentially will run a gRPC server in the container. So when you run the this server, Flyte will automatically load the sensor or the agent in the memory and then register to the registry. And then you update the image of your deployment here, and then deploy to your Kubernetes cluster here. Here you can see I have 2 agent deployment, one for development purpose and one is for production environment. And then check the yeah. So by default, all the task requests will be sent to this endpoint, like sent to the production environment. But you can also override the endpoint. For example, if I just add a new file sensor, I don't want to run in this deployment. I can override the endpoint, and if I run the file sensor tags, I run in this deployment. Yeah. And then here I just register my sensor, my workflow which has sensor to the cluster. For here is keep running for because I didn't have any file in the bucket. So here I try to upload the file. And then wait a few seconds. Yeah, it's a C. Yeah, you will check if the file is in the bucket. If it's CC, you will run the downstream tags. Yeah. So to summarize, like the agent allow you to run like the BigQuery tags locally. You can very easily to test any backend plugin in local environment, and then you don't need to rebuild or restart the propeller. And then the most important thing is that every agent deployment is stateless. You can easily scale up, scale down based on your workloads. And then you can also have a scenario deployment, one for production, one for like testing. Yeah. So the future work is that we will like to add more agent. We want to create an agent universe, and then we want to add more agent and sensors so people can use this feature. Yeah, that's it. Thank you. Any questions?
I have a comment as usual, but this is just amazing work. I don't think you emphasized enough. The code, you can now run all services, anything that Flyte can connect to, everything locally, as if the local development is now supercharged, right? Like, so all of the Kubernetes pods, Kubernetes, Sage, Spark jobs, distributed training, Elastic training, all of that used to run locally, but you couldn't connect to Snowflake, you couldn't connect to SageMaker, you couldn't connect to all of those things from local prior to this work. With this, you can now connect to anything. So now open up a Jupyter notebook, start writing your code, everything will run, save it, hit Flyte run remote, and boom, everything will run remote as it was running locally without any code changes. And I think that's just a massive boost in productivity. So yeah, and it's super easy to add contributions. So I'm hopeful that everybody will add more and more agents. It's going to be hard to keep up, but
yeah, the two that I really, would like to see is a Lambda Labs integration. So they have a programmatic API now where you can request an instance, and I guess the trick will be to like figure out how to run code in there from a Flyte task. And there are all sorts of similar platforms like Vast AI, like basically for cheaper GPUs. I guess a second comment here is the sensor pattern basically opens up like a new way of orchestrating that hasn't existed in Flyte before. And yeah, I don't think we really realize this, where you could have like if we had infinitely running tasks, we can basically treat them as like these orchestrators of various other tasks, depending on like external assets being available or not. So yeah, it's going to be very interesting to see, what kinds of use cases this opens up.
Kevin, this is amazing. It would be awesome to see kind of a roadmap. I just heard Niels' suggestions, and I feel like it would be great to put this at least in a timeline about, what's on the horizon, what you have seen, and what you're considering, and what comes next. It would be great to see that somewhere.
Yeah. For sure, yeah, I will create an issue and then list all the agent we want to add, and then
Yeah.
all the feature and the roadmap in that issue, so people can easily to know what to contribute to the agent service. Yeah.
Yeah, I think Stripe, Spotify, and some others are already contributing, and we would love to make sure that this people are not duplicating their work. Like just would be great to potentially have a board of just agents as a separate board.
Yeah.
One thing I also wanted to emphasize was that we all should understand that Flyte always supported kind of like agents underneath. And the reason why they exist is long running tasks is essential for calling services or doing sensor activity. You do not want to use containers. You just don't want to start up a container and waste it doing nothing. This is multiplexing lots and lots of requests onto the same container. So the cost of operating an agent is actually dramatically low. It's very, very low. And because it horizontally auto scales to multiple nodes, it starts up at almost nothing. It's like a few pennies a day can scale up to whatever you want. So it's essential to understand the cost dramatically changes with agent work. So if you are writing plugins that use containers to call services, prefer agents. Long running, better, stateful, and cheap.